In the last video, we covered how to create a setup and how Fusion uses visual elements to make defining the setup quick and intuitive. Now that we have created our setup, we'll look at Fusion's adaptive clearing operations to start roughing out our part. Let's start by making sure our setup 1 is active and begin by facing our stock. To do this, I will select the facing operation, which opens the facing dialog box and adds a facing operation to the active setup in the browser on the left. Before we begin programming, I would like to point out the 5-tab layout. There will be more in-depth coverage of these tabs in the next video, but I do want to point out that this layout will be consistent throughout every toolpath operation in Fusion 360. The first tab is the Tool tab, where I'll select the tool I want to use for this operation. Thanks to the model intelligence built into Fusion 360, that's actually all I have to do to generate this face toolpath. Now let's go to the Heights tab where I can get a great visual representation of the different heights for this toolpath. Fusion automatically selects the stock top as the top height of the toolpath and the model top as the bottom, so only excess stock material is removed. Directly referencing the stock and model is the model intelligence that makes creating operations in Fusion so easy. Once we have faced our part, we need to consider our roughing operations. Fusion has two primary options for roughing strategies. One is 2D adaptive clearing, and the other is 3D adaptive clearing. Here's a great example of the adaptive strategy in action. The adaptive algorithm is designed to maintain a constant radial load on the cutter. It does this through keeping a constant engagement angle based on the user-specified optimal load to avoid load spikes that can cause tool breakage. Because of this constant load, we can cut with the full flute length of the tool. This distributes tool wear and increases cutter life. While constant engagement angle strategies are common in the industry, the adaptive clearing algorithm is proprietary to Autodesk, meaning there are still updates and optimizations being developed to this day. You will see all milling operations in Fusion are separated into 2D and 3D strategies. 2D strategies are used for prismatic or 2D features and are driven solely from contours. Therefore, all 2D toolpaths require some form of contour selection. 3D toolpaths are for 3D features and are driven from the model surfaces. As a result, 3D toolpaths require no selection to generate. However, 3D toolpaths can be contained using a combination of boundaries and height containments. First, we will use a 2D adaptive to rough the outer profile of the part. For our tool, I'm going to select a flat end mill from the library. Because this is a 2D strategy, we must define a contour for the strategy to follow. So in the Geometry tab, I will select the bottom contour of the part. Fusion shows a blue area denoting where the toolpath will remove material, which helps you make the correct selection before you even generate the operation. If the selected contour isn't what you were hoping for, you can change the contour by selecting it again. This opens the Contour Selection Manager where I can adjust my contour selection by continuing to select contours on my model. Selections highlighted in blue represent contours I have selected, and selections highlighted in black are Fusion's attempt at closing the profile. I can select a closed contour and Fusion will automatically attempt to close my contour selection, or I can select an open contour, which allows me to select individual contours to form a partial chain or individual open contour. One trick is to hold the Alt key to force Fusion to just select the partial contour. Note that it is possible to automatically detect open contour selections. Once I have selected a contour I'm happy with, I can choose to accept the current contour, which will update my selection, cancel the current contour, which will keep the current contour but remove any changes, or delete the current contour, which will remove the current contour from the selection altogether. I'm going to accept this contour. In the Heights tab, since our facing operation has removed our top layer of stock, I'm going to change our top height from stock top to model top. You'll notice that our bottom height has defaulted to the contour that we have defined. In the Passes tab, I'm going to set my optimal load to 30% of the tool diameter. This parameter sets the target engagement for the algorithm, and there's more information available in a tooltip that appears when you hover over the parameter name. Tooltips like this are available for nearly every parameter in Fusion manufacturing. To set the optimal load, I could simply type in a value, or I could right-click on the dialog box and select Edit Expression. This expression references the tool diameter, meaning that this value will update automatically even if I change tools. This captures my intent and reduces the amount of work needed to make a change. I can now edit the expression and set my new optimal load condition. To set my new expression as default, I will right-click and select Set as New Default. Now, whenever we create a new 2D adaptive clearing operation, my optimal load will retain the new expression. I will also edit my stock to leave and set axial stock to leave to 0. This means my toolpath will go to the full depth. For this operation, I could select the multiple depths option and specify a step down. However, because adaptive clearing allows cutting with the full flute depth, I will leave this option unchecked. Next, I will use 3D adaptive clearing to rough the rest of our part. As you can see, Fusion has remembered the tool from the previous operation. Since adaptive clearing is a 3D toolpath, it is generated from the model geometry and does not require any contour selection. I can click OK here, and adaptive clearing generates a toolpath that covers the entire model, removing all excess stock material that it can. You will notice that the toolpath is remachining the area which has been cleared by our 2D strategy. To fix this, I will add a boundary to our toolpath. I will edit the toolpath by right-clicking the adaptive operation in the feature tree and selecting Edit. Now, in my Geometry tab, I will change my machining boundary to Selection. This allows me to select a contour directly off the model to contain my toolpath. No need to pull the geometry off with legacy-style extraction tools. I will select the outside profile of my part. You'll now see that we have a tool containment setting with 3 options. It'll be much easier to explain these options with a visual, so I'll hover over the options to bring up the tooltip. As we can see, the tool inside boundary option will machine inside of our boundary, but the whole of the tool diameter will always remain inside the boundary. Tool center boundary will machine inside the boundary, but our tool center line will never cross the boundary. Finally, tool outside boundary will machine inside the boundary, but our tool can fully cross the boundary line. For our example, we'll select tool outside boundary so that our tool can cross over the boundary and machine these flat regions where the shoulder breaks. Before we recalculate our toolpath, I'll also navigate to the Heights tab and set my top height since the part has already been faced. While I could use Model Top option again, I want to point out that heights can be set with the selection directly off the model. Again, no need to create or extract geometry to control your toolpath. And these selections are associative, so if the face, edge, or point I select changes, the toolpath will update as well. I will now recalculate my toolpath, and you'll notice our boundary has limited the toolpath to inside the outer profile of our part. Now we have roughed side 1 of our part, and we can run a stock simulation to see what has been removed. To start simulation, right-click on the setup and select Simulate. We have a few options here regarding what we wish to display during our simulation. I'm going to take Stock Box, which shows the stock. I will also set my toolpath display mode as Tail. This will only show the part of the toolpath which has just been completed. I'll hit play, and I can control my speed using the slider below. Now that we have covered the basics of roughing, let's take a closer look at how the toolpaths are structured and explore the 2D and 3D finishing options in Fusion 360.